Hello, my dear students. Hope all of you are fine and well and keeping safe. Today, I want to start, or I'm going to start a new chapter today in physics. The new chapter is gravitation. The word gravitation actually, it is the force of attraction between the two bodies. So before we come to this chapter, that is the word gravitation, I want to give you some introduction regarding with this term. Okay, so how this word gravitation has come. So a long time back, a famous scientist, Sir Isaac Newton, during his childhood, he was just sitting under the tree, an apple tree. Let us take an example, apple tree. And suddenly an apple fell down. Okay, and it fell on his head. And he looked up and he thought, why this apple fell down? Why can't this apple remain in the air? Or why can't it go up? Instead of falling down, it may remain in the air, it may go up. Why all these things cannot happen? Why it has to fall? Then again, it made some confusion to him. And secondly, he has got a very broad concept, okay, regarding physics, to say. So again, he thought about the planetary motions, about the planets, about the moon, earth, okay, all these planets. So, and again he thought that why not the moon? Okay, he used to look upon the moon also, and moon remain in the sky, it remains there. And why not that moon fell into the earth or into the ground? Since the apple it fell down, so moon also has to come. It also has to fall down. It has to fall. So it made him confused. And he finally tried to investigate or try to observe or made some experiment. And after his studies, okay, after his findings, he came that there is some force acting between the two objects, and that force is the gravitational force. Okay, and because of the force between the earth and an apple, the apple fell down. Again, because of the force between the earth and the moon moves around the earth likewise. Okay, so finally he come to the conclusion that some force is acting between the two bodies, and that force we call it as a gravitational force, and we call it as a gravitation. So now again he proposed a law also, which we call it as a law of gravitation, or we call it as a universal law of gravitation. Okay, now according to the law of gravitation, it is stated that every particles of matter in this universe attract each other with a force. Okay, every particles of matter in this universe, they are attract with a force which is directly proportional to the product of their masses and inversely proportional to the square of the distance. So he proposed a law there. Okay, and this law he proposed due to the finding of the force, on the finding of this gravitational force. So these are the laws. Okay, this is the law of gravitation. We call it as a Newton's law of gravitation, or we call it as a universal law of gravitation. So according to the law, every particles of a matter is attracted by a force which is directly proportional to the product of the masses and inversely proportional to the square of the distance between them. So to understand this law, okay, there are the two bodies here, a body A and body B, having the mass of body A m1 and mass of the body m2. And these two bodies are separated by a distance d. That means they are far away. Okay, and finally these two bodies get attracted later on due to the force. And these two bodies separate by distance d. And what happens here is that the mass A can attract a body having a mass B, or the mass B and the mass B can also attract a body having a mass A. That means there is an attraction between each other. A can pull a body B, or B can pull a body A. So for that, the force is exerted here. Okay, force. The force is exerted on the A also as well as on the B also. So now the total distance, and you see the total distance is d here. And if A will pull a body B, okay, the B will cover a distance d. Again, if B will pull a body A will move a distance d. So therefore, d into d is considered as d square. Okay, so the total distance is d, but the product of the distance is d square. Remember that. So for that, according to the universal Newton's law of gravitation, what it stated is that the force is directly proportional to the product of the masses. Because as I told you just now about the law, okay, every particles in this universe, they are attracted by a force which is directly proportional to the product of their masses, and the masses are m1 and m2. So F is directly proportional to m1 and m2. Make this as equation 1. Then again, F is inversely proportional to the square of the distance. Square of the distance means d square. Inversely proportional, that means 1 upon d square. Make this as equation 2. Now combine this equation 1 and equation 2. Combine it together. So what I can do is that F, 2F are there, I can take F as common here. So F is proportional to m1, m2 into 1 upon d square. Combining these two, equation 1 and 2. Then F is proportional to m1, m2 into 1 will be m1, m2 divided by d square. Okay? Or F equals, now this sign of proportionality is z here. So F equals to z. Now instead of writing proportional, I can write it here z here. F equals to capital Z, m1, m2 divided by d square. Now this g is known as the universal gravitational constant. Z is known as the universal gravitational constant. Okay. Now this proportionality is a constant here, and this constant z is known as the universal gravitational constant. Okay. So this is the law, which we call it as a law of gravitation, or the universal law of gravitation, or the Newton's law of gravitation.